All right, everybody. So this problem asks us to plot our 2 points, which I've already done, and then connect those points with a line. And then we're going to use that graph, that line, to write an equation in slope-intercept form. So the first thing I need to do is to connect the points with a line. So I'm going to do that, making it as straight as I can. There we go. Now, if I'm going to write an equation in slope-intercept form, it's going to be important to remember what slope-intercept form is. So y equals mx plus b, where m is the slope and b is the y-intercept. All right? So on my line here, I'm going to put in a slope triangle. And I know it's been a while since you've thought about all this, but slope is equal to delta y, or change in y, over delta x, or change in x. So if I look at my slope triangle there, my delta y, from this point right here where the line crosses the corner of a grid, to this point up here where it also crosses the corner of a grid, my delta y is up 2, which is a delta y of positive 2. My delta x from this point going to the right up to that point is the change in x. We go to the right 1, so the delta x is a positive 1. So my delta y is 2 over 1. Then that is my slope. And my y-intercept is the place on the line where it crosses the y-axis. So here's my y-axis right here. My line crosses the y-axis right there at the point right here. And that is the point 0, 2. And remember that when we're talking about the y-intercept, we focus on the y part there. So our equation is going to be y is equal to m. M is my slope. My slope is 2. X plus b. Oh, no, it's not 2. You guys should have slowed me down and said, whoa, Mr. White Wolf, you must still be on break there, man. This is not 2. What should that be? Anybody? Oh, the slope is 2, but that's not 2. Man, I'm all over the map here. Should be 1. So that's going to be plus 1. All right. After that confusion, are we okay? Does everyone see that and sort of remember all that? Or is there anything someone would like me to explain? All right. All right, on this first problem here, we're taking a slope and a point right here, and we're going to graph it, and then we're going to write the equation, just like we did in the warm-up, okay? So there were 2 points in the warm-up, so this is a little different. So our point here that we're going to plot is 0, 4, right there, and our slope is negative 2/3. Remember that since slope is equal to delta y over delta x, that's going to be negative 2 over 3. We could also write 2 over negative 3, negative 3, and we might do that as well. So we're going to look at it both ways probably. But so negative 2 for our delta y means we go down 2, and positive 3 for our delta x means we go to the right 3. So our point is going to be right there. And then we can continue on with that same slope, down 2 to the right 3, so we need a point right there. And we can't go any more in that direction. Now, when I said that we could also think of this as 2 over negative 3, that means that our delta y is up 2 and our delta x is to the left 3. So this was down 2 and to the right 3. This is up 2 and to the left 3. So from our blue point there, up 2 and to the left 3 means we have a point right there. And that's all we can get on that one. So now I'm going to graph that, connecting those as best I can. And it is not perfect, as is life. Now we're going to write an equation, and we'll write it in slope-intercept form. So y is equal to m negative 2/3 x plus b. And remember, b is our y-intercept, which in this case is the 0.04. So the 4 there is what we're going to include as our b value. Now this particular slope and point lend itself very well to graphing and writing the equation. What is it about the point that makes the equation nice and easy to write? So my question was, what is it about the point that I gave that made writing the equation easy? Anybody? Come on, just go for it. Be brave on this Tuesday, first week back. All right. I'll tell you. It's the fact that I gave you the y-intercept. So all I had to do was include the y value from that y-intercept. So I gave you the y-intercept, so it makes writing that equation pretty easy. Now in this one, I'm giving you a slope and a point, and we're going to do the same thing. And you're going to see that it's going to be a little bit tougher, I think. Let's find out. So the point that we have is 4, negative 3. So right there, 4, negative 3. And the slope is 1/2. So that means our delta y over delta x is equal to 1 over 2. That can also equal negative 1 over negative 2. It's the same thing. So 1 over 2 would say go up 1 to the right 2. And there's a point. Or we could say go down 1 and to the left 2. And there's another point. And then we can just follow that same pattern. Down 1 to the left 2, down 1 to the left 2. And there is our line. Oh, I guess I was wrong about this one. So this one isn't as bad maybe as I thought it was going to be. We can connect those points. And we're real fortunate in this situation. And the reason why I say we are fortunate is that we are given, again, the y-intercept there. We have that as one of our points. So in our equation, we can just write y is equal to 1/2 x, and then our b value there, 0, negative 5. So we have a negative 5 is our b value. Questions on that one? So when we get a point on our y-axis, so our y-intercept, when it's real clear where it is, it makes finding the equation pretty easy when we're given a slope and a point. Now, sometimes we're given 2 points and we're asked to find a line. Remember, x1, y1, this is just a point that's on the line. And m is the slope. So this is the general form of the equation called a point-slope form of a linear equation. How about I highlight it? A point, x1, y1, slope form of the linear equation. So what's pretty cool about this is that you can use different points, and it doesn't make any difference. So first we're going to figure out the slope, and I'm going to use, remember that slope, whoa, I don't want that. Slope is equal to delta y over delta x. And I'm going to make it, can anyone see what the slope is on this line? Well, remember that when we find slope, the delta y, delta x, we can go y1 minus y2 over x1 minus x2. So we're going to use our y1 is going to be the green one, and our y2 is going to be the red one. All right, and x2. So y1 is negative 1, y1, minus y2 is negative 4. So y1 minus y2 over x1, 1, whoops, minus x2, negative 2. And so that equals, well, negative 1 minus a negative 4 is the same as negative 1 plus 4. So that's going to be positive 3 over, and 1 minus a negative 2 is 1 plus 2, so that's 3. And so our slope is 1. And we can actually see that right here, to the right 1, up 1. Our slope must be 1. But I wanted to go through this process just to remind you. So the y here and the x here, those are our variables. And when we're writing the equation, they just stay as variables. Okay, so y minus, in this case, our y1 was the negative 1 there. So negative 1. So I just wrote y minus y1, y minus negative 1, is equal to our slope, which is 1, times the quantity x minus x1, x minus, and our x1 is the 1. And I'm going to put that in parentheses just because it's a good practice to put those, when we substitute a value in, to put it in parentheses. So now I can rewrite that as y plus 1 is equal to, and because I'm multiplying the parentheses times 1, I don't need to put that 1 there, but I'm going to just to remind us that that's the slope times the quantity x minus 1 inside parentheses, just like that. So this is the equation written in point slope form of this line right here. Now I can do another equation in point slope form using the other point, this point. Okay, so we're going to do it again. Y minus, and it says y1 here, but it doesn't matter which point you use. So y minus the y value is y minus negative 4. Is equal to the slope is 1, times the quantity x minus x1, x is negative 2. And I'm sorry that I used red for the slope and red for the point. That was bad form on my part. I apologize. Now I can rewrite this. Y plus 4 is equal to the 1, that's the slope, times the quantity x plus 2. And so because this is the equation of this line, both of these are the equation for this line. And so that means that these two equations are said to be equivalent. Notice how close that is to the word equal. They're equivalent, which means any point that we put in for the x and the y value, if we plug 0 in for x here, and negative 2 in for y there, and negative 2 in for y there, and 0 in for x there, both of these equations will come out to be true. Because the point 0, negative 2 is a solution for both of those equations. So they're equivalent. Questions on that? Okay, I'm going to pause the video here. All right, so now we're going to take each of those two equations that we just found, this one and this one, and we're going to show why they're equivalent, or one way to see that they are equivalent. So we're starting with, we found that our slope was 1, and we plugged in this point for our x1 and y1 here. And I'm just going to rewrite it. Y plus 1 is equal to, now I could distribute that 1 and I'd get x minus 1, of course, because I can just get rid of this, which means I can get rid of the parentheses as well. And now in order to solve this, to write it in slope-intercept form, remember slope-intercept form is y equals mx plus b. So our y has to be isolated. And here our y is not isolated because we're adding 1 to it. So we can subtract 1 from both sides, and we get y on the left-hand side is equal to x minus 2. Does anyone have a question about that? Because if that's confusing you, you're not going to understand the importance of what I'm showing you. So is there anyone who wants to ask a question? All right. So now we're going to use this other point and we plugged in the -4 for y1, and we plugged in -2 for x1. So now we're going to rewrite that as y plus 4 is equal to 1 times the quantity x plus 2. And again, I can get rid of those like that and do y plus 4 is equal to x plus 2. And because our goal is to write it in slope-intercept form, we have to get the y value by itself. And again, here the y value isn't by itself because we're adding 4 to it. So to undo that adding 4, we do the inverse operation, which is subtracting 4. And the result is y is equal to x minus 2. So the slope-intercept form of this line is y equals x minus 2. And right here, the slope-intercept form of this line is y equals x minus 2. So no matter if we use this point and plug it into the point-slope form, as long as we have our slope correct, or we use this point and plug it into the slope-intercept form, the y-intercept form, when we find it, is the same in both of them. And I hope that when you see that, you go, wow, that is so cool, Mr. White Wolf. Thank you for showing me that. That's awesome. Anybody out there? It's awesome, right? Yes. Yes, Sophia, Elliot, thank you. Following along, recognizing the beauty of mathematics. It's like a 35-footer by Dame Lillard, right? Anybody? Lillard? Nobody watches the Blazers? Sophia likes it. All right, good. All right, so now what you're going to do is you're going to choose one of these 2 points. I don't care which one. Well, first you're going to find the slope. So remember, to find the slope, it's delta y over delta x. And you can do delta y by doing, let's see, I'm going to use green. y1 minus, I'm going to change this. I'm going to change the color of this. Sorry. It wasn't, I didn't think about how that was going to be. So y1 minus y2 over x1 minus x2. So that means that this point is our x1, y1 point, and this point is our x2, y2 point. So first you're going to find your slope using this equation. You're going to plug it in for your slope here. And then you're going to pick one of these 2 points, I don't care which, and plug it in for x1, y1. And then you're going to convert to the slope-intercept form of the equation, which is y equals mx plus b. All right, I'm going to pause the video here and give you a chance to work on that. When you're ready, you should pause your video watching at home too. And when you're ready, restart and we'll go over it now. All right, so I'm going to try to give myself enough room here to do it using both points. So y minus y1, I'm going to do the green one first. So the y1 is 1 is equal to, and I need to figure out my slope here. First things first. So I'm going to put in a slope triangle right there. Those 2 points are helpful. My delta y, as I go from left to right, is down 3. So that's going to be a delta y of -3. and my delta x is to the right 2. So my delta x is 2. So my slope is negative 3 over 2. It goes down 4, thank you. Was that Elliot? Thank you. All right, so we have a slope of negative 2 because it's negative 4 over 2. And then in my parentheses here, x minus x1, I'm going to have x minus, and my x1 is also 1. So 1. All right. Now what I'm going to do is I'm going to distribute that negative 2. So I'm going to have y minus 1 on the left, negative 2x plus 2 on the right, because negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Now I'm going to add 1 to both sides so I can get my y term by itself here. And I'll get y is equal to negative 2x plus 3. So the one of the point slope versions of this line is right here. And here is the slope intercept form. So now we're going to do the other equation. We're going to do y minus, and we'll use this point down here now. So the y value is negative 3. Is equal to, well, the slope is still negative 2 times the quantity x minus, and the x value is 3. Now we're going to distribute that negative 2, and we're also going to write this as y plus 3. So we have y plus 3 on the left. Distributing that negative 2, first to the x, we get negative 2x. Then to the negative 3, negative 2 times negative 3 is positive 6. And now to isolate our y value there, we're going to have to subtract 3. So we get y all by itself on the left-hand side minus 2x plus 3. Woohoo! Look at that. Isn't that a thing of beauty? Oh, it's gorgeous. Questions? We're going to do both of the, use both points again. So in this one, we'll start with the red point, y minus, y minus. The y value of the red point is 0. Oh, that's nice. Is equal to the slope. Remember that the slope is equal to delta y over delta x. So we can maybe see right here this delta y over delta x is 2 over 8, which is 1/4. So in our equation, we can put in our slope of 1/4. So notice that over here, I used the equation for slope. And over here, I used the slope triangle for slope. You can use either one. I bet most people will find the slope triangle easier for now. And then x minus, and the, the x value for the red point is 3. I thought I mixed them up, but I didn't. So on the left-hand side, we don't need to do anything. It is already in y equals, because the y minus 0 is just y, And on the right-hand side, we still have to distribute that 1/4. So 1/4 times x is 1/4 x. And then 1/4 times -3, well, that -3 just moves up to the denominator over the 4, because 1/4 times 3 is the same as 1/4 times 3 over 1. We multiply across the numerators to get the 3 and across the denominators to get the 4. And I just kept that negative right there out front. So there's our equation in slope-intercept form. Now, when we are writing it in I used green there. I screwed up the colors on that. I apologize. I'm having a hard time with colors this morning, not doing what I want them to do. So the y value on the green point is, so y minus -2 is equal to the slope, which is 1/4, times the quantity x minus, and the x value is -5. All right. So on the left-hand side, we have y plus 2, because y minus 2 is the same as y plus 2, is equal to, and I'm going to distribute that 1/4 to the x, and I'll get 1/4 x, and then this is going to be x plus 5, so I'm distributing the 1/4 to the positive 5, and I will get plus 5 over 4. Now I need to get my y value by itself by subtracting 2 from both sides. And when I do that, I get y is equal to 1/4 x plus 5/4, and then this subtract 2. I'm going to make a fraction that is equal to 2, but has a denominator of 4. So I'm going to subtract 2. So this needs to be equal to 2 with a denominator of 4. That means my numerator is going to be 8. So I just changed this to a subtract 8 over 4 because I had this fraction right there. And I need you guys to be working on that kind of stuff because fractions are important. So 5/4 minus 8/4, they have the same denominator. That's why I used a denominator of 4. 5 minus 8 is 3. So this is going to be, is -3, excuse me. So that's why it's going to be -3 over, and the denominator stays the same. And wonderful, look at that. They came out to be the same. Questions? You mean, when is what more efficient than using a slope triangle? Right, just straight away. So, Elliot, great question. Great question. Thank you for asking. So, if I were just given these 2 points and I drew the line in here, how would I know what the y-intercept was? Well, the x value is 0, but what's the y value there? Well, you sometimes can tell, Elisha, that's true. But sometimes you can't. So if you can't see the y-intercept, that's when this is going to be more efficient. And because it is sometimes more efficient, I need for you guys to be able to do it. So I need you to know the process and be able to do it. Does that make sense? I could write problems all day long that you couldn't tell the y value here. I could just write problems that um, would be impossible for you to know what the y value was. But this process would allow you to find it. Now, the problems that I've been using so far, the y value is really clear. And the reason why I'm doing that is because I don't want to write a really hard problem straight away. Notice that these problems have gotten progressively more difficult. All right. Um, this problem's a little different. Pause the video here and give it a shot. Let's go over this now. So we're going to start with y minus y1 is the 5 is equal to our slope, which is negative 2/3 times the quantity x minus x1 is the 4. All right. So hopefully you got at least that far, and that is the equation written in point slope form. It's a very handy form, to be honest. If someone says just write an equation for this line and they give you the slope and they give you a point that's not the y-intercept, then the point slope form is the easiest. But if they want you to write it in slope intercept form, then you have to do some distribution. So we have y minus 5 is equal to that negative 2/3 x. And now when we distribute here, the negative 2/3 times the negative 4, it's going to be positive 2/3, and I'm going to just do it like this at first, times 4/1. So I'm going to do that first step there, so maybe you can see the multiplication a little easier. So we have y minus 5 is equal to the negative 2/3 x. And then it's going to be 2 times 4 is 8 over 3 times 1 is 3. So it's going to be plus 8/3. All right? Is everyone good up to this point? Elisha's good. Anyone else? Elliot? What about Will, Dafu, Sophia, Lewis, Jade? How you feeling? Okay. All right. Well, I hope everyone's following along and understanding, those of you who didn't respond. To get y by itself, we have to add 5 to both sides. Now, when we do that, we have y isolated on the left, which is what we want. We have that negative 2/3, that's our slope, times x. Now, I have the plus 8/3, and I need to add 5 to that 8/3. So I'm going to need to turn this 5 into a fraction with a denominator of 3. So I need this fraction to equal the 5 because we're adding it. So 3 times 5 is 15, and so we have 15/3. If you're not sure about that, ask a question. All right? We have y equals the negative 2/3 x plus, now we can just add the numerators. 8 plus 15 is 23, and the denominator stays the same. And there is our slope-intercept form of the equation. Questions?